section 13.1, which is our first day of sequences. This is just kind of a general lesson that just introduces the concept of sequences, okay? So I really don't think it's going to be tough at all, okay? Look at this first problem. They give you a formula. S sub n is 2n minus 1. They want you to find the domain and the range. Well, the domain, those are the n values. The range is what you get, which is your S of n value. So if your formula is 2n minus 1 and n is 1, then it's just going to be 2 times 1 minus 1. Literally, all I do is just put that 1 into the formula. So 2 times 1 is 2, 2 minus 1 is 1. If n is a 2, that's 2 times 2 minus 1, that's 4 minus 1, which is a 3. If n is a 3, it's 2 times 3 minus 1, that's 6 minus 1, which is a 5. If n is a 4, it's 2 times 4 minus 1, that's 8 minus 1, which is 7. If n is a 5, it's 2 times 5 minus 1, that's 10 minus 1, which is 9. And if n is an n, then it's just 2n minus 1. So you just stick in those values of n, and you end up with a list of numbers, 1, 3, 5, 7, 9, blah, blah, blah. Okay? Okay, the next one is very comparable. The formula is just a little bit different. Okay? So guys, here's what I need you to know. Here's where people maybe get a little bit confused on this stuff. This says a sub n, and this says a sub 1. So if you're finding a sub 1, then the value of n is 1. So you just put it into that equation. So it's just 3 times 1 squared plus 1. 1 squared is 1. 1 times 3 is 3. 3 plus 1 is a 4. You can do it in your head, or you can just put it in your calculator. For the next one, n is 2. So it's 3 times 2 squared plus 1. 2 squared is a 4. 4 times 3 is 12. 12 plus 1 is 13. You have to follow the order of operations if you're doing it in your head. 3 times 3 squared plus 1. 3 squared is 9. 9 times 3 is 27. 27 plus 1 is 28. The next one is 3 times 4 squared plus 1. 4 squared is 16. 16 times 3 is 48. 48 plus 1 is 49. The next one, n is 5. So it's 3 times 5 squared plus 1. 5 squared is 25. 25 times 3 is 75. 75 plus 1 is 76, and that's it. Okay, so very basic. You guys, basically, here's your sequence. Look, if I had to write this as a sequence, it'd be 4, 13, 28, 49, 76, and that would be your sequence. Each of those numbers is called a term. Which term in your sequence, okay? Question B, basically the same thing, okay? So find the first 5 terms. So you're going to go b sub 1, b sub 2, b sub 3, b sub 4, and then b sub 5. That would be the first 5 terms. And then see how this says b sub n, and that says b sub 1. So for that particular term, n is 1. So it's just 2 times 1 plus 1 over 2 times 1. 2 times 1 is 2. 2 plus 1 is a 3. On the bottom, 1 times 2 is a 2. For the next one, use the formula over here that I'm highlighting in yellow and just put a 2 in for n. So it's just 2 times 2 plus 1 over 2 times 2. 2 times 2 is 4. 4 plus 1 is a 5 over 2 times 2 is a 4. b sub 3, 2 times 3 plus 1 over 2 times 3. 2 times 3 is 6. 6 plus 1 is 7 over 6. Okay, b sub 4, 2 times 4 plus 1 over 2 times 4. 2 times 4 is 8. 8 plus 1 is 9, so you get 9/8. So the next one is 2 times 5 plus 1 over 2 times 5. 2 times 5 is 10 plus 1 is 11, so that would be 11/10. So first term, second term, third term, fourth term, fifth term, done. Okay? Okay. For these sequences right here, I'm not even going to really talk about them directly. I'm just telling you that's what a sequence looks like. Usually there is a pattern to the sequence, and then you can find the next sequences or the next term or like the 50th term, or you can also find sums. So those are the things that we're going to be doing throughout these next 3 lessons. Okay, find the nth term. Okay, so guys, what you have to do on these ones is you actually have to come up with a formula. Okay, so let me tell you this. For this lesson, coming up with the formula is tougher than the other 2 lessons, because on the next 2 lessons I give you the formula, then you just stick numbers in and manipulate it and you get your answer. But on this lesson there's no formula, so it's a little tough. It's kind of abstract. You have to look at it and you have to like go, okay, this is kind of what I'm seeing, so it's a little weird. Okay, so for the first value of 1, everybody put n equals 1 right there. For the value of 1/3, n is 2. For the value of 1/9, n is 3. For the value of 1/27, n is 4. Okay, so see the first term 1, I'm going to make it a 1/1 because that's the same thing. Okay, so now I'm trying to come up with a formula that works for every value of n and gives you the term that you're looking for. Okay, well, I can see on the top of them they all have a 1, so I've got that done, right? Then I want you to look at it, guys. Look at the numbers 3 and 9 and 27. Does anybody notice anything about those numbers? It's a 3. What do you mean it's a 3? It's a, they're called a power of 3, right? So like 3 to the first is 3, 3 to the second is 9, 3 to the third is 27. So it's going to be like a 3 to the something. Okay, now let's think about this. If n is 2, then you get a 3, which is a 3 to the first. So if n is 2, you get 3 to the first. If n is 3, you get 9, which is 3 squared. So n is 9, you get 3 squared. N is 4, you get 3 to the third. Can anybody tell me my exponent on my 3? 2 gives you a 1 on the exponent. 3 gives you a 2. 4 gives you a 3. What's my formula? N minus 1. Thank you. 3 to the n minus 1. Okay. Now, I know that's not super fun. That's what I'm saying. You have to just kind of stretch yourself a little bit and try to come up with the formula. Do I think that this is going to be on the final? No, I don't. Okay. But I want to have a clear conscience when you guys go into that final. So, you know, like I said, and I think it's a great introduction as well. Okay, a number factorial. All it means is write down that number, write down the number that's smaller, the next number, until you get all the way down to a 1. Okay, so for example, 3 factorial just means start with a 3, then what's 1 lower than a 3? A 2. What's lower than that? A 1. You're down to the 1, and then you just multiply those together and you get a 6. That's all it is. Okay. 5 factorial, guys, is 5 times 4 times 3 times 2 times 1, which is 120 when you multiply it out. Let me show you how to do that on your calculator. Okay, grab your calculator, and I want you to hit 5. Then up at the top left corner, go 1 to the right and go 1 down. See that PRB button? Hit that. Then go right, enter, enter. There's your 120. Okay, now if this were on the final, which I think it is not going to be on the final, but if they wanted you to evaluate 10 factorial, I would do this. 10 times 9 times 8, blah, 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 down to a 1. Okay, took me 5 seconds to write that down. So I think I'd write something that at least I know what it stands for. So they'll go 10, PRB, right, enter, enter, and you get 3628800. So it's 3.6 million is what that's equal to. Okay. The definition of 0 factorial is 1. Okay. I know it's strange that it's not 0. Basically, all these rules that these mathematicians came up don't work unless 0 factorial is a 1. And you can put it in your calculator, 0, PRB, right, enter, enter, and you get a 1. Okay. Question E, this one's just a little, E and F are a little, not really weird, but just look at it. So write this with me. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 On the bottom, you have 5 times 4 times 3 times 2 times 1. Well, the top 5, 4, 3, 2, 1 cancels with the bottom 5, 4, 3, 2, 1. So then all you have is 8 times 7 times 6, which is 336, and that's your answer. Okay? Now, you don't have to write that whole thing out, because what if you have some huge number like 85, right? Let's show our work like this. 85 times 84 times 83 times 82. Now you guys know we're going to go 80, 79, 76, you know, blah, 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 78, blah, 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 all the way down to 1. Well, that's the same thing as 82 factorial. And the reason I stopped right there is because I have exactly an 82 factorial on the bottom. Then as well on the bottom is a 5 times 4 times 3 times 2 times 1. So now I can see that this 82 factorial will cancel with that 82 factorial. So now I'm just going to put this in the calculator, guys, with parentheses around both of them like that. So go parenthesis, 85 times 84 times 83, close it off, divided by parenthesis, 5 PRB, right, enter, close it, enter, and your answer is 4,938.5. So that's what factorial means. Okay? Am I going too fast? Okay. Recursive. You guys, a recursive sequence. Here's what you need to know about a recursive sequence. It uses the previous term. So you can't find this one until you know the one up above, because it's part of it, okay? Now everybody listen right here for a second to this explanation so that you understand, okay? This will help you to understand. A sub 1, A sub 2, A sub 3, A sub 4, blah, 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 A sub n, okay? If we're at A sub 4, then the previous term is 3. If we're at A sub 3, the previous term is A sub 2. If we're at A sub 2, the previous term is A sub 1. So if I'm at A sub n, what is the previous term represented by? Look, A sub 4, A sub 3. The A sub 3 previous term is A sub 2. A sub 2 is A sub 1. So A sub n would be A sub n minus 1. Yep, you just subtract 1. 4 minus 3 is 4 minus 1 is 3, 3 minus 1 is a 2, etc. So A sub n minus 1 stands for the previous term. That's really all you have to remember. Okay? So look at question 4. Find the first 5 terms. So as soon as I see that, see how this is labeled right here, guys, A sub n? Then I'm going to label my first 5 terms, and I'm going to go A sub 1, A sub 2, A sub 3, A sub 4, and then A sub 5. Okay? Now I want you to look at the formula. See this A sub n minus 1? I want you to draw an arrow to it, and I want you to write the words previous term. That's what that means. So they told us that the first number is 2. So A sub 2 means 3 multiplied by the previous term, which is a 2, subtract 2. 3 times 2 is 6. 6 minus 2 is 4. Let's do it again. 3 multiplied by the previous term, which is 4, subtract 2. That's 12 minus 2, which is 10. Do the next one. 3 multiplied by the previous term, which is 10, minus 2. That's 30 minus 2, which is 28. And the last one is 3 multiplied by the previous term, which is 28, subtract 2. So I'm going to go 3 times 28, subtract 2, and it's 82. And yes, I think if it were me, and if this were on the final, I would show that work, how I got those numbers. Okay?
They also include, well, most time they include like an A to the first.
Yeah, they have to, or else you can't find the next one, and then you can't find the next one. So yes. Okay? Okay, here's another one. Same thing, you guys. So find the first 5 terms. So you have A sub 1, A sub 2, A sub 3, A sub 4, and A sub 5. Look at your formula. Highlight that A sub n minus 1, draw an arrow to it, and say previous term. Okay? So I know the first one's a negative 3. So the next one is going to be 2 times the previous term, which is a negative 3, plus 4. That's a negative 6 plus 4, which is a negative 2. Do the next one. 2 times the previous term, which is a negative 2, plus 4. That's negative 4 plus 4, which is a 0. Next one. 2 times the previous term, which is a 0, plus 4. That's 0 plus 4 is a 4. Next one. 2 times the previous term, which is a 4, plus 4. That's 8 plus 4, which is 12. You know, if I were you, I think I'd write it as an actual sequence, and it would look like that, and I'm done. Okay? Who says got it? Let me see how we're doing. Okay, great. Okay, so this funny symbol, you guys, is called a summation. Okay? And this is what summation means. It means add up your sequence, basically is what it means. Okay? See this word summation? It begins with the word sum, and you guys know sum means to add things up. Okay, so at the bottom, I want you to write n equals or k equals. It doesn't matter if you do n or if you do k. If you look at question 6a, they did n. 6b, they did k. It doesn't matter. But guys, look, if this is the n, then there's an n there. If this is a k, then there's a k there. It's not like you would use an n and there'd be a k in the formula. Okay, so basically the bottom number or bottom information is where you start. The top number is where you end. So you begin with the bottom and you end with the top, and then right here is your formula. Well, if I could erase, that would be great. Okay, and this right here is your formula. Okay, so let's go ahead and do 6a. So you start with n equals 2. Then you go to n equals 3. Then you go to n equals 4. And then you go to n equals 5. And you find out what those are equal to. And then you add them together. That's all you have to do. So if n is 2, you have 2 squared. If n is 3, you have 3 squared. If n is 4, you have 4 squared. And if n is 5, then you have 5 squared. So 2 squared is 4. 3 squared is 9. 4 squared is 16, 5 squared is 25, and it is 54. Very simple. Okay, question B. First I'm going to put a 1 in for k, then I'm going to put a 2 in for k, then I'm going to put a 3 in for k, then I'm going to add them together. Okay, so you just go 2 times 1 squared plus 1. Now k is a 2, so put plus 2 times 2 squared plus 1. Then put a 3 in for k. So it's 2 times 3 squared plus 1. You can put the whole thing in your calculator. You can go term by term by term. I'm going to do it in my head. 1 squared is 1. 1 times 2 is 2. 2 plus 1 is 3. The next one, 2 squared is 4. 4 times 2 is 8. 8 plus 1 is 9. The next one, 3 squared is 9. 9 times 2 is 18. 18 plus 1 is 19. So you go 19 plus 12. Your answer is 31, and you're done. That's it. Who says I'm fine? Let me see how you feel. Okay, good. Let's keep going. K factorial. First I'm going to do k is 3, then 4, then 5, then 6, and then add them together. So this is 3 factorial plus 4 factorial plus 5 factorial plus 6 factorial. Now, if this was on your final, then I think I would probably take the time to go 3 times 2 times 1 plus 4 times 3 times 2 times 1 plus 5 times 4 times 3 times 2 times 1 plus 6 times 5 times 4 times 3 times 2 times 1. Okay? If it was on my homework, I think I would just put it in my calculator. So I'd go 3 PRB, right, enter, plus 4 PRB, right, enter, plus 5 PRB, right, enter, plus 6 PRB, right, enter, and my answer is 870, and I'm done. Okay, look at question D. Question D is kind of weird. Does anyone see why it's weird? It ends at N. Yeah. Do we know what N is? No, we don't know what N is. So you really can't find it. but we can set it up. Okay, so if k is a 1, it's 1 over 1, which is a 1. If k is 2, it's 1 over 2. K is 3, 1 over 3. K is 4, 1 over 4. Blah, 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 until k is n. So the last one is 1 over n, and it looks like that. We're just going to leave it just like that. Okay? All right, next one. This one's kind of weird. Okay? N equals 1 to n equals 4 of 4. So first I'm going to do a 1, then I'm going to do 2, then I'm going to do a 3, then I'm going to do a 4, and I'm done. Add them together. So my formula is 4. So first I'm going to go into that formula, and wherever I see an n, I'm going to put in a 1. But there's no n. So what's it equal to? Just 4. There's n is 1. There's n is a 2. There's n is a 3. There's n is a 4. And that gives me 16. And I'm done. Okay. Now, here's a formula. This is a shortcut. Okay. You guys know that a constant is a number that doesn't have any letters in it. So look. K equals 1 to k equals n. This is n equals 1 to n equals 4. It doesn't matter if it says n or k. Of c of 4. 4 is a constant. So the formula is take your n and times it by c. So take your 4 and times it by 4 and you get 16. Okay? Now you're probably like, yeah, that's great, but it was super easy to just put 4 plus 4 plus 4 plus 4, right? What if this was 400? Do you want to write out 4 plus 4 plus 4 plus 4 400 times? No. It's way easier to just go 4 times 400 is 1600. Okay? So the formulas work well if it's a very long summation. Okay? All right. These two right here are probably the toughest ones of the whole lesson. So you're going to want to watch. Now they give us the sequence and they want us to come up with the summation. Okay? So everybody write the summation of n equals 1. You could put k equals 1. It doesn't matter. Okay? Now look, guys, we have to come up with a formula. So if n is 1, you have 1 squared. If n is 2, you have 2 squared. If n is 3, you have 3 squared. This right here, this last one, I think n is probably, what do you think? N is 9. Yeah, so we're going to go from n equals 1 to n equals 9. And then somebody tell me the formula. N squared. Yeah, that's it. Okay, that one's easy. B is not so easy. Okay, make sure that you do this, guys. Underneath, put n equals 1, n equals 2, n equals 3, n equals 4, n equals 5, and n equals 6. So this is going to be a 4-point question, just so you guys know. The summation of n equals 1 to n equals 6. That's 2 of the 4 points right there. Okay? You have to look at the signs separately than separate from the number. Look at the signs. Negative, positive, negative, positive, negative, positive. They're alternating. Okay? So right here, I want you to put alternating signs. You have one of 2 things that's going to be correct. It's either going to be negative 1 to the nth power, or it's going to be negative 1 to the n plus 1 power. Okay, so everybody watch me figure it out. If n is a 1, I get a negative. So which one of these, 1 or 2, if I put in an n, gives me a negative? Well, the first one would be negative 1 to the first. What is negative 1 to the first, guys? What is negative 1 to the first? Negative 1 to the first is negative 1, right? Negative 1 to the 1 plus 1. That's a negative 1 in parentheses squared. That's a negative 1 times a negative 1, which is a what, everybody? Positive 1. So this number 1 you use if the first sign is negative. That's the formula you use. The second formula you use if the first sign is positive. because 1 plus 1 is 2, a negative squared is a positive. Well, guys, our first sign is a negative. So now I can see that my formula is negative 1 to the n. Now that doesn't give you the number. All that does is give you the signs. Okay, and everybody listen. If n is 1, you get a 1. If n is 2, you get an 8. If n is 3, you get a 27. Sorry. If n is 4, you get a 64. If n is 5, you get a 125. If n is 6, you get a 216. Can anybody see the formula? N, and then what? N cubed. N cubed. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. I'm not worrying about the sign. I'm just trying to get that number. So here's the 4 points on this question, guys. Look, a point for knowing you started at 1. A point for knowing you got to 6, a point for having that, and a point for having that. So it's a 4-part thing you have to think about. Okay? Who says got it? Let me see. Raise your hand if you're good. Okay. Probably the toughest part right now. All right. Now, here's the deal. In a couple of days, I'm going to give you so many papers. So many papers. And those papers are to get ready for your final. Okay. Oh, sorry. On the one of the papers has a big list of formulas that you need to know. On the formula sheet are these summation formulas. Okay. Do I think that this is going to be on the final? No. But what if it is? Each question's worth like 15 points out of 150. You miss one, that was painful on your grade. You know what I mean? So what if you don't know the formula and you get a summation? So yes, memorize them, but the whole time you're memorizing, I want you to think it's probably not going to be there. Okay? Okay. Why do you use these formulas? Okay? You use these formulas if n is large. If your n is really big, then this is why you're going to want to use the formula. It's going to save you some time. Okay? Look at the first one. K equals 1 to k equals n of c. Let me give you an example. That would be the summation of k equals 1 to k equals 100 of 5. Put in a 1 for k, you get a 5. Put in a 2 for k, you get a 5. 3 for k, you get a 5. 4 for k, you get a 5. So the formula would be to take this c, which is here, times n, which is here. So that would just be 5 times 100, which is 500. I'd rather way rather use the formula than write 5 out 100 times and then realize it's 500. Okay, let's do the next one. Let me give you an example. So if you have the summation of k equals 1 to k equals 120 of k. So the first number would be a 1. Then the next one would be a 2, and then the next one would be a 3, and then the next one would be a 4, and all the way up until the last one's 120, and then you add them together. So the formula is take your value of n, and for this problem right here, your n is 120, because look, your n is at the top. So now all you do is just plug it into that formula, guys. So it's just going to be 120. 120 plus 1 is 120 divided by 2. And when you put that in your calculator, you would get 7,260. So the formula is just a shortcut when the value of n is really big. Okay? This one right here. Say an example would be the summation of k equals 1 to k equals 94 of k squared. Well, it matches up perfectly. Look, k squared, and then I know that my value of n is 94. So all I'm going to do is put it into that formula. So it's going to be 94. 94 plus 1 is 95. 2 times 94 plus 1 gives me 189 divided by 6. So I'm going to go 94 times 95 times 189, close it off, divided by 6, and that gives me 281,295. It's just a quick way to find it. Yes, sir?
Where did you get 94 for n?
because in that little example, I made it up to be a 94. Yeah, it's just like an example that represents that equation. Okay. Okay, this last one right here, here's an example that shows the formula. K equals 1 to k equals 132 of k to the third. So that's the example that I just made up. You don't have to know that. And then you just use the formula. So here's your formula. And for this particular problem, your n is 132. So you'd go 132. 132 plus 1 is 133. Divided by 2. Whole thing in brackets. Whole thing squared. So go 132 times 133 equals, divided by 2, hit enter, 8,778, then hit x squared, and it's this big, huge number, 770,53284, put commas, 77 million would be what it is. Way faster to just use the formula, okay? Who says gotcha? Let me see how we're doing. Okay, we're almost done. Okay, here we go. I didn't leave myself a lot of room to do these. I think my formatting is off from yours. So anyway, I don't have a lot of room. So it's going to be squishy. Okay, see this 3 right here, guys? Do you see how it's multiplied by the k? I'm going to take the 3 and I'm going to pull it right there. You can push it in front if it's multiplied by something. So now I have 3 multiplied by the summation of k equals 1 to k equals all of these right here changes to 100, 100, 100, and c change that to 124. So the only time you're going to use these formulas is if that top number is big. So change them. Okay, please. Okay, so k equals 1 to k equals 100 of k. And then you look at the formulas that we just went through, and the formula for the summation of k equals 1 to k equals n of k, the formula is n times n plus 1 divided by 2. But I know that n is 100. So the 3 is going to be part of it. Then I multiply it by n, which is 100. 100 plus 1 is 101 divided by 2. So that is, when I put that in my calculator, I get 15,150, and I'm done. That's all you have to do. Yes, sir?
Are we supposed to memorize those kind of equations we just did above?
Answer his question.
Yes.
Yes. Should you spend a lot of time memorizing them?
No.
No, because I just don't think it's going to be there. Like, don't get all crazy about it. But I would know. I don't think it's going to be there, but if it is, and you don't know the formula, it's over. Okay? Okay, this one right here. Do you see how those are added? Okay, so I'm going to rewrite it as the summation of k equals 1 to k equals 100 of k to the third, plus the summation of k equals 1 to k equals 100 of 1. So the formula for the summation of k equals 1 to k equals n of k to the third, which is what I have right here, is going to be this. N times n plus 1 in parentheses divided by 2, whole thing squared. This is the constant formula. And that constant formula you already have, k equals 1 to k equals n of c, is c times n. So every place I have an n, I'm going to put a 100. So this k to the third right here is going to follow this formula. And where I see an n, I'm going to put in 100. So this is 100. 100 plus 1 is 101. Whole thing's divided by 2, and it's squared. Then I'm going to go plus. Now I'm using this formula. It's going to be c, which is a 1, times n, which is a 100. So when I put this in my calculator, it's going to give me a big old number. I'm just going to read it out to you. 255,02600. So 25.5 million is what you end up getting. Okay, next one. Question C.
What do you want, Miss?
Oh, wonderful. Are those for me?
Yeah.
I haven't paid yet.
You can just pay to the office.
Okay,
36.
awesome. You can just put them right there. Thank you.
It says how much in there.
Okay, it tells me how much. Okay, great. Thank you. Okay, so question C. Say it again.
You get green, you get
Tomatoes.
tomatoes?
Mm-hmm. They're kind of tiny, huh? I can't wait. Okay, let's do the next one, okay? I'm going to erase the formulas, okay? Because I don't have room. Actually, you know what I'm going to do? I'm going to scroll. 124 and 100. Okay. Here we go. The only time you're going to use these formulas is if you're adding so many numbers together it would take you all day. Okay? Like this. So do you see how I have a term, and a term? Each of those terms is going to have a summation. So summation of k equals 1 to k equals 124 of k squared. Then you're going to do the next summation of k equals 1 to 124 of negative 7k, plus the third summation of k equals 1 to k equals 124 of 2. Now, remember before, when we had two things that were multiplied together, one of which was a number, we just pushed the number out in front. So I'm going to take that negative 7, I'm going to get rid of it, and I'm going to write it in front of the summation. Okay? For every single one of these, n is 124. So the formula for k to the second, I'm just going to write down the generic formula underneath. So it's n times n plus 1 times 2n plus 1 all over 6. Then I'm going to put a minus 7. Then the summation for this, k equals 1 to k equals 124 of k. I have to look at the of k formula, which is n times n plus 1 over 2. Then I do the third one. That's the constant formula, and that's going to be c times n. So now I'm going to go into every one of those n's and put in 124. So it's just going to be n, pardon me, not n, 124. 124 plus 1 is 125. 124 times 2 plus 1 is 249 all over 6. The next one, negative 7 times 124 times 125 over 2 plus your c, which is the 2, that's the constant, times n, which is 124. I would just do the top. I'd go parenthesis 124 times 125 times 249, close it off, divided by 6, and I get 643,250. Do the next one. Parenthesis 7 times 124 times 125, close it off, divided by 2, enter, and I got minus 54,250. Then this is plus 2 times 124 is 248. Put that all in my calculator. And I get 589,248. That's my answer. Figure out the equation, write it down, stick in your n, done. It's really not too tough. Who says I gotcha? Let me see. Okay, this one's kind of tough. Okay, look right here. Why is this tough? Can anybody see? It doesn't start with 1. The formula only works if you start with 1. So I want 5, 6, 7, 8, 9, 10, 11, 12, all the way up to 100 for my k's. I don't want to have to add them, but I also don't want 1 through 4. And the formula only works if you start with 1. So what am I supposed to do? Go ahead.
Subtract 5 from 100 and just make it 95 on top.
No, because good thinking, but you can't do that because your terms would be different. You know what I mean? Like if you start with 1 versus starting with k equals 5, those are different starting points. So you can't do that. What are we going to do?
I was just wondering, if you didn't know the formula on the test and you just went to the extent and did every single one, would you get credit?
I don't know. I don't know, but can I be honest? I don't think you're going to see it. Like I think I would almost say 0. As close to 0 as I could say. But I wouldn't say 0 because I don't want to feel guilty if it's there. Yes, what are we going to do?
So could you start it as if it was from 1 and
Okay,
then
just a sec. Sorry. Shh. Okay, go ahead.
could you start the problem as if k were 1 and then once you have that answer subtract 4 factorial from that answer?
Not factorial, but yes, you're getting there.
Solve.
Okay, Julie, you want to try?
I'm just gonna say just to multiply the equation, the k to the third equation.
Say it again, I'm sorry.
Still use the equation, but multiply it by 2.
Okay. We are going to multiply by 2, Julie. We're going to take this 2 and we're going to pull it out right there. So you're right with that. Go ahead, hon.
You solve the equation normally, but then you have to solve for 1 and then solve for 2, solve for 3, and add those together and subtract it.
You're exactly right. You're exactly right. And that makes sense if you think about it. Look right here. So everybody write it like this. The summation of k equals 1 to k equals 100. Put a 2 in front of it, and it's of k to the third. And that's great, except I don't want the 1 or the 2 or the 3 or the 4. Those can't be in there. It has to start at 5. So now I'm going to subtract the summation of k equals 1 to k equals, what's the last one I subtract? If I want to start at 5, go to 4. Don't subtract out 5 because 5 needs to be there, of k to the third. So I did all of 1 through 100, and then I took out the 1 through 4s. That's going to give me the 5 through 100s. Okay, it is kind of cool. Yeah.
When you have the 2 in front of this,
Yes, thank you, honey. Yes, I did that just to make sure you were watching. I love it when you correct me. Okay, so the formula for k to the third is this. So it's going to be 2 times n plus 1 all over 2 whole thing squared. This is minus 2. Again, summation n times n plus 1 all over 2 whole thing squared. For the first guy, n is 100. So it's going to be 2 times 100 times 101 divided by 2 whole thing squared. The second one, the n is a 4. So I'm going to go minus 2 times 4 times 5 divided by 2 whole thing squared. So I'm going to go 100 times 101 equals, divided by 2, I get 5,050. I'm going to square it and times it by 2. I get this huge number, 51,005,000. Add them in, 51 million. Do the next one. 4 times 5 is 20. Divided by 2 is 10. Square it, you get 100 times 2 is a negative 200. Now just figure out what that is. So 51,005,000 minus 200 is 51,004,800. 51 million is your answer. Okay? That's it. We did it. 3 more lessons. That's all you guys have. That's crazy. Crazy, crazy, crazy. Okay, you still have 30 minutes. Everybody turn your desks and get into your groups, okay?